Today we will be talking about substitution. And substitution is when you replace one value or variable for another value or variable. So if we look at example A here, it says evaluate y equals 7x plus 3 when x is negative 3. So we're going to substitute x for negative 3. So y equals 7 times negative 3 plus 3. We substituted that in for x, and then we can solve it. 7 times negative 3 is negative 21 plus 3, so y equals negative 18. Number 2, it says find y. 2y equals 5 minus 4x when x is 8. So again, we'll substitute 8 for x. 2y equals 5 minus 4 times 8. So 2y equals 5 minus 4 times 8 is 32. So then 2y equals 5 minus 32 is going to be negative 27. And then we can divide both sides by 2. And you can leave it as y equals negative 27 over 2. You could leave it as a simplified fraction, or you can make it a decimal, and in this case it will be negative 13.5. So we can use the same substitution process to actually solve systems of equations. We talked about graphing systems of equations to find the solution, and I also talked about why that may not be the best way to solve those systems, because if the intersection point is a decimal, then it can be hard to see exactly what decimal that would be, or if the numbers are large, then you're having to graph a very large graph. So substitution is a way to get that answer a little bit quicker and neater. The first step in doing so is solve one of the equations for one of its variables. So get one variable by itself in one of the equations. Get a variable by itself. And for today, that's what we'll do. That's what we'll have. All the variables or all the equations will have a variable by itself. And then we substitute. We replace one equation into the other, and then we solve. Make sure you write your answer as an ordered pair if possible. So let's look at some examples. And you may recognize these equations from our graphing lesson, and that we can verify those answers that we got from graphing with substitution. So we have y equals 2x plus 5, and we have y equals x plus 10. So we can substitute one in for the other because they both equal y. So I'm going to substitute, and it's going to be x plus 10 equals 2x plus 5. And then we want to get x by itself. Subtract x. 10 equals x plus 5. Subtract 5. You get 5 equals x. So that's our x value, but in order to solve this, we have to plug 5 back in. It doesn't matter which equation from the original that we use to plug 5 back in. I always recommend the least nasty one. I think Monica's equation here is least nasty because it does not have any number in front of the x, but either one will work. So y equals x, which is 5, plus 10, so y equals 15. So our ordered pair for a solution becomes 5, 15. And if you remember yesterday, that is the answer that we got from our graph when we were asked the same question. Now, example number 2 says x equals 2y plus 5 and x equals 2y. So we're going to substitute 2y in for x because they both equal x. X equals 2y plus 5 and x equals 2y. So we can set them equal to each other. So we get 2y equals 2y plus 5. I'm going to subtract 2y from both sides. 0 equals 5. Well, that's not true. Whenever we get an untrue statement when we do substitution, that means there is no solution. So this is untrue, or else it's called not true. So no solutions. Now, if you would have gotten a true statement, let's say we would have gotten the statement 3 equals 3. That is a true statement. This is a true statement. And what that means, you have infinite many solutions. Infinite many solutions. So if we get x equals a number or y equals a number, we have one solution like we had over here. If we have a statement that's not true, then there are no solutions, what we have here. And if we get a true statement, then there are infinite many solutions. Those are the three possibilities that we could have. Now, on the next page, I'm going to have you work with your partner on these 4 problems. And after a couple minutes, we'll come back and look at the solutions and see if you and your partner got these correct. All right, now let's look at these answers. For the first one, I got 1, 2. For the second one, I got 10 equals 10 once I did the algebra, or if you could have subtracted 10 from both sides right here and 0 equals 0 would have been your final answer. And that means you have infinite many solutions. Then the third one over here is -3, 2 a solution. So what you would have to do is you plug in x and y into each equation. So you see I plugged in -3 for x into the top one and 2 for y in the top one. And we get a true statement, 2 equals 2. So this ordered pair right here works in this top equation. It's a solution to the top equation. But is it a solution to the bottom equation? And you can see right here I plugged in my x and y into the bottom equation, and I got a non-true statement, 2 equals -44. So that means that -3, 2 is not a solution because it does not work in both equations. For a solution to be true in a system, it has to work for both equations, not just one. And then the last one, I got 1, 3 when I solved it using substitution. And then my graph, you see that the 2 lines cross right here at 1, 3. Right, so this was just a brief introduction to solving by substitution. And in these examples, we already had either x by itself or y by itself, and you just had to set them equal to each other. Tomorrow, we'll go into a little bit more detail and discuss what happens if y is not already by itself in the equations. So thanks for watching. Make sure you hit the like button and subscribe.